Okay, I'm going to show you DC signals and how they look on the oscilloscope. I am essentially going to be doing the first part of Lab 24, so these 9 steps right here. What we're going to need is a power supply example. We'll need the oscilloscope, and we'll need 2 resistors. In addition to that, I'm also going to pull out some multimeters. So to do that, come over here and type those parts in. You want your power supply. So here's our power supply. We're going to need our multimeters. So we're going to pull 2 of these out. And we need some resistors. Okay, looking at the lab, you know that your resistor needs to be a 10K ohm and a 1K ohm. If I scroll down here a little further, you'll see they're hooked in series. R1 is our 10K ohm and our 1K ohm is R2. The positive side of our power supply is connected to the 10K ohm. The negative side of my power supply is connected to the 1K ohm. Okay, so let's go back then and set that up. We're going to turn this resistor into R1. That's 10K ohm, so we set its value to 10K ohm. And this one can butt right against it. That's R2. It is already 1K ohm. Okay. Last part that we need to put on here is the oscilloscope itself. So let's grab one of those, and we're going to pull the oscilloscope out. I'm going to dump that on the screen over here. Okay, let's hook up our circuit first. Positive side, if you remember, goes over to the 10K ohm. So I'm clicking and put that in there. Let's make this positive red. And the negative side is going to come down here. And click in, we're going to make our negative side black. Okay, this is a very simple series circuit. The reason I've pulled 2 multimeters out just to measure the voltage drop. So I'm going to take these multimeters, they're set for voltage. We'll put multimeter number 2 down here, multimeter number 1 right here. And let's look at the voltage over the 2 resistors. Oh, I got that backwards there. Delete that wire. This is a black, so it's a negative guy. He comes down here. And I'll make him black just so I know that. And then this guy is the red. He goes over here. And we'll make him red too. Okay, on this same thing here. Now, he's black, so he's going to go on the lower side. And he's my red. Up there. Okay, so our circuit's set up. It's ready to go. We're going to check here at our steps. This is turn the oscilloscope with these settings: a DC sense, 2 volts per division, 1 millisecond per centimeter on our time. So coming over here, let's look at our oscilloscope. We want 1 millisecond, so we'll just set that to 1 ms. Remember, it's an auto ranging, so the volts per division will auto set up. So our oscilloscope is set. Go back to the lab. Let's look what we got to do next. Turn the DC power supply on to 6 volts, and then we want to hook our oscilloscope up where our ground clip is on the negative side, and our positive probe is, we're going to initially start out with the A portion here. So let's go ahead and do that now. So to set the power supply to 6 volts, click on the power supply. We're going to say our voltage is 6. It's done. Our oscilloscope, the positive probe is going up over here. The negative probe needs to come to the ground side right here. Okay. When I have that in place, then we can start the simulation. And then you look here, you see a line on the oscilloscope itself. When we're looking at that line, it says over a 20 volt signal. Now, if you remember back, there's 20 volts over these 10 squares. What does that mean? We take our 20 volts, divide it by the 10 total vertical squares. That means each square is equal to 2 volts. So this is 2 volts, this is 2 volts, and this is 2 volts from the zero line right here. So in looking at this, there is our 6 volt signal. Okay, so let's verify what we see here. When we look at the oscilloscope, we simply see a line straight across. It means nothing to us until we relate it to the scale on the oscilloscope screen. And you look here, voltage is our main concern. We're looking at a scale of 20 volts. There's 10 squares vertically here. So if we remember, take 20 volts divided by those total 10 squares. So 20 divided by 10 gives us a setting of 2 volts per square, or 2 volts per division. So from the 0 mark, if we count up 1, 2, 3 squares times 2 volts to the division, that's a 6 volt total from the 0 baseline. That is what we're supplying our circuit, 6 volts. And you come over here, look at the multimeters, we can confirm that we do have 6 volts being applied when you look at the multimeter. There's a larger voltage drop across this first resistor. Our 10K ohm resistor sees the bulk of it, 5.45 volts there. And 1/10 of that, or 0.545 volts, is also 545 millivolts, is 1/10 of this value. Add those two together, because voltage drop 1 plus voltage drop 2 equals the total applied voltage in a series circuit, according to Kirchhoff's law. Adding them together, you get approximately 6 volts. And so we're able to verify that signal. Now the question is, what does it look like if we change the oscilloscope around? To change the oscilloscope, we first have to stop the simulation. We're going to take those wires and delete them. And then we're going to simply switch or reverse the polarity. So my positive wire, which was originally going to the 10K ohm resistor, is now going to go to the 1K ohm resistor here. And my negative wire will go up to our positive terminal right there. And then go ahead and start the simulation again and see what our oscilloscope shows up with. Look at that. Our line is down here below the 0 mark. It's down in the same amount of squares though. We're still 20 volts. You got 10 squares, so 20 divided by 10 is 2 volts to the square. 1, 2, 3 squares down, and multiply that out, that's 6. Well, why did it go down? We simply reversed the polarity. Nothing else has changed on here. We just reversed the polarity. So it's important that you have your oscilloscope hooked in properly so you observe proper polarity when you're using that. Okay, this is the first half of Lab 24.